Okay, here we go with quotient of powers. So this is basically, in layman's terms, this is division of exponents. So we have the formula right here. It says a raised to the m divided by a raised to the n. And that just equals a m minus n. So it's important that we notice the difference that there's an m and an n. For this rule, it's important because the order of subtraction matters here. It has to be the numerator's exponent minus the denominator's exponent. So it would matter, it would make a difference because in subtraction the order does matter. So if I said 3 minus 2, I'm going to get a 1. But if I had 2 minus 3, I'm going to get a negative 1. So that's going to make a big difference if you do the subtraction in the wrong order. So it's always the top exponent minus the bottom exponent, or if you want to use better vocabulary, the numerator's exponent minus the denominator's exponent. So let's go ahead and do an example. So right here, if I had x to the fifth minus divided by x to the third. So we have the rule here, we have common bases, so that's good. We have both x's here. So all I have to do is subtract the numerator's exponent, 3, or 5 minus 3 here. So what I have is 5 minus 3, which is just 2. So I'm left with x squared. Okay? Let's do another example. You can very well get a negative number or a negative exponent doing the quotient of powers. Okay, so let's go ahead and do an example like that. So if I just switch these, x to the third divided by x to the fifth, right here now what I have is 3 minus 5. So 3 minus 5 is actually a negative 2. So we have a negative x raised to the negative 2. Alright, so they have to be the same bases. If they weren't the same bases, you could not divide them. For that case, you couldn't multiply them together. They would just have to be written next to each other. That would imply that they were being multiplied. So let's do a quick example like that. So if I had x raised to the third times y squared divided by x right here, all I would do is these common bases are the only ones that can get divided by each other. So I'd have 3 minus 1, which would just be 2. So I'd have x squared, and it would just have to be multiplied by y squared. The y cannot get divided. That's why the rule has both a's here and a common a here. It means that they have the same bases. Okay, so another thing that I didn't mention before is that whenever I have numbers doing quotient of powers or just division of exponents, if I ever have numbers or coefficients, I just treat these as just like I would normally treat them. Just treat these just as normal. So this would say 16 divided by 4. 16 divided by 4 is just 4. And then I just complete the process, as we know, 4 minus 2. So I just have x squared. So that is the simplified version of that. Alright, so let's go ahead and look at this one. So the same thing, if I have coefficients or numbers in front of my variables, all I do is treat them like I normally would. So I'd say right here, this reduces, both of these are divisible by 2. So what I say is that I have 1 over 3. 2 divided by 2 is 1, and 6 divided by 2 is 3. So then I'd have 3 minus 1. So 3 minus 1 would just be w squared. This can also be written as w squared over 3.